Hello and welcome to the show. My name is Bret, and this is my channel where every Thursday we get to talk about DevOps, Docker, Kubernetes. This week we're all about ARM, talking about ARM containers. What does that look like? How do you get started in ARM? All the different new flavors of ARM we have these last few years. And before we get to our special guest, I want to give you a couple of announcements. So if you haven't been in this channel before, please subscribe. This is basically all focused, like the channel name, on DevOps, specifically containers in DevOps. So like the things I just mentioned. And I have guests on most of the time. Sometimes we just do Q&A. Sometimes we just, hang out and chit chat about what it's like to work in the world of DevOps and modern engineering teams. And sometimes we do things not on YouTube. So this is also streaming on Periscope and on Twitch. So you can go check it out wherever you prefer to watch your live stuff. But I also have a Patreon where you can either become a member and get special benefits like monthly hangouts where we do Discord video chats where we just kind of have like a little, like a water cooler moment with some friends and people in the DevOps community. But you don't have to actually sign up with money. You can just click the follow button on patreon.com/Bret Fisher, and you'll get all my updates. So it's the updates about the open source that I have, content updates on courses, any new blog post I might put out, any new live show guests like today. You would have saw that. And you probably get like 1 or 2 a week, maybe. So it's not a lot of spam. It's just a little. And you can just click the follow button. That's free. Or you can thank me with buying me a coffee. And that's how this show gets sponsored. I don't have paid sponsorship ads or anything like that. It's all from you. Thank you so much for doing that, patrons. All right. So real quick, couple announcements. One, Docker this month is turning 8. So every year in March, actually it was probably March. So this is April 1st, a little late, but in March, Docker celebrates their birthday. And this year they just launched a competitive challenge. So this is a challenge I'm giving out to you all that you see what you can do here. Right now, I think it's actually all Docker captains that are in the top 3 on this. And you get basically a swag box if you run through all the challenges, all of the things that it has you do there. They're basically all Docker challenges. And this was all created in open source by the Docker captains. So go check that out. It's some learning. Hopefully you'll learn something. All right. And then also at DockerCon 2020, sorry, 2021. That's this year, right? That's coming up in May. It's free, just like all the other online events, or most of them. And please sign up. I'm actually going to be doing the live part of this not all day, but off and on throughout the day this year, just like we did last year. So I'm going to have a bunch of special guests. We're going to be talking about GitOps, automated deployments, all the stuff like GitHub Actions and automated CI, and just some cool stuff with containers. So it's going to be a great time. Sign up over at dockercon.com. And that's it. That's enough for the silly announcements. But now let's bring to the stage someone who I've known for now a half a decade, Alex Ellis. Hello, Alex.
Hello. Apologies for the clicky-clacky typing. Apparently, when you're in the backstage, the microphone is still on.
So that's a brand new feature. That's a brand new feature.
In.
I did not know. Sorry about that. I should have warned you. So Alex is the founder of OpenFaaS, and he's been on the show multiple times before. So you may have seen him last year. We were here about this time last year talking about all the things that he's doing today, and it's a lot. So we're definitely going to get into that. He's also a CNCF ambassador, so you will see him around the world of CNCF projects, giving out stuff, talking at KubeCon events, doing online webinars, blog posts. He's all over the place. So today, we're talking about, I think, one of your favorite subjects, I think, ARM, and that's a wide topic. So you, the audience, the reason we're live is because we're taking your questions. So you're going to help drive the conversation. So if you have any questions about ARM and all of its possibilities, because we could talk about Apple, we could talk about Raspberry Pi, we could talk about servers with Graviton. Yeah.
We should talk about all of them.
We should talk about all that.
I'd be interested to know if people have what specific questions you've got, what you tried that you just loved it because it works so well, and maybe something that you tried didn't work so well and you're wondering if it's any better now, because things have changed a lot over the last 5-6 years.
Yeah, that's true. I mean, even just, I feel like in the last year, we've like since the Raspberry Pi 4, these new Graviton 2s on AWS, and now Apple's M1, it's like ARM seems to be like a contender everywhere instead of just the thing that you used in, IoT or mobile kind of stuff.
RAM on this one now.
How much
having
RAM?
a bit of a lag again.
Yeah.
We've also got 8 gigs of RAM on this bad boy. So, I mean, that just changes the conversation. People wondering, could we run Kafka on a Raspberry Pi with 1 gig of RAM? And the answer is absolutely no. Are you crazy? Even with a cluster, it's still only 1 gig of RAM. It's a JVM.
Right.
Now, happier on that amount of memory.
Yeah. That's on the Raspberry Pi 4, and it's still like less than $100, right, for a board with 8 gig of RAM. Seems like we have some lag. We were just fine 2 minutes ago.
We're having some trouble somewhere.
You're back.
I think we're back. Yeah, I'm not sure where we're having trouble. I wouldn't be surprised if Virgin Media having issues. Usually all right for streaming. So the Raspberry Pi 8 gigs of RAM, it's just so much more versatile because you've just got that headroom that a lot of applications do need. Whether they'll go as far as 16 gigs of RAM, I don't know. But at that point, that's the same as a maximum you can get in an Apple ARM laptop at the moment. So it could, you could get there at some point down the line.
Yeah, I mean, doing containers on a 1 gig RAM ARM device, you're probably not running more than a few containers. So it's been. You have. Go ahead.
The great thing about the ARM devices, I have one, and I can't remember if I've got it. It's downstairs at the moment. I have one running a.
Might have you restart your browser. Hey, try to refresh your browser and come back in. Maybe that'll help establishing a new connection. See if we can get Alex back. All right. While we're waiting on that, let me look at the chat.
I think it's my internet because my ping just keeps dropping out.
Oh, is it? Yeah. I was going to say, try to refresh your browser if you think it's maybe browser related, but because we are streaming you through a browser.
The pings are they're just stopping and starting again. Let's see how we can get on. I mean, it's nothing that I'm running on my network. If anything, it's my ISP. So having that amount of RAM is just so useful because at one point you couldn't even get Raspberry Pi to run Kubernetes anymore because it really needed a minimum of 2 gigs right at that time. It used to work fine on one, and then it got to the point where it just didn't work on one at all. It needed 2. Obviously, Darren Shepherd has done a great work of minimizing it and making it easier to access in K3S, which I'm sure we'll touch on later. And now K3S itself is kind of a bit heavyweight for even the Raspberry Pi 3 because of I/O. It is a constrained device. And so what I did is one of the things I've created is off the back of OpenFaaS is a mini version of it that just uses Containerd instead of Kubernetes. And if you look at Containerd, it is actually normally in a Kubernetes cluster right at the bottom running containers. And you mentioned earlier, could you run more than a few containers on a Linux machine? Is it me now? Okay. So yes, you can, because the great thing about Linux is that a container is just a process. It doesn't have overheads that we're used to with VMs. So you could only run 1 or 2 VMs on a Raspberry Pi with 1 gig of RAM, probably, and do something useful. But when it comes to containers, they're just normal processes. And so with this Faasd project, I have this treasure trove portal with discounts and email updates that I send to sponsors each week. And you log in with your GitHub account. It runs on there. It's pretty stable. It's just a Raspberry Pi 3, and it's all running through Faasd. And then I have something that gets webhooks from when people buy stuff on Gumroad. It tells me on Slack. When somebody becomes a GitHub sponsor, again, it forwards it to me on Slack. And when they, if somebody cancels, it sends me a thumbs down with their name. And so then I kind of get a bit bummed out by that. But all of that's running on the same Raspberry Pi with OpenFaaS, Prometheus, Alert Manager, NATS, and cram a lot in. And so, yeah, I've been using a Linux desktop for the last 4 or 5 months. And just the speed of using Docker it's like a completely different ball game, right? Because everything is native on the machine.
Yeah. And I never had those early Raspberry Pis, so I didn't understand the struggle early on. Like my introduction was actually the Pi 4B. So I came in at like the best time for Raspberry Pi, and now it's I've done some Docker and Kubernetes playing on it, but it's mostly just a Raspberry and or whatever you call it, the
Raspberry
RetroPie.
Pi OS.
I'm using RetroPie. Yeah, so it's my game machine upstairs for when people want a retro game on 40,000 different Nintendo games. But
what's your favorite retro game?
For when I'm playing with friends, honestly, Gauntlet. I like 4-player Gauntlet is.
I'm gonna have to look that one up.
Yeah, it was.
What platform
is
it on?
Well, you can get it on. It was arcades, but it also came out on like every console at some point. So it's on, like, you probably can find a version of it on everything Super NES and newer. But it was a top-down. It looked kind of, I don't know how you call it, a real-time strategy kind of game, I guess. But there's no strategy. It's just 4 people on the screen running around in a dungeon, and it was cooperative. So in the 80s. A cooperative arcade game for 4 people was basically unheard of, and they kind of nailed it with that. And then they had Gauntlet 2 and Gauntlet 3, and then they came out, I think, on like Nintendo 64. They had a bunch of Gauntlet games that were different. Anyway, so that's my favorite.
I'd say for me it would be Mortal Kombat. I used to love playing that and going through different characters, and when they would freeze and ice and throw the spear in and stuff like that. Yeah, I like the leg sweeps. The other one is. What was the one where he was like Haruken?
Oh, that was Street Fighter. Street Fighter 2.
Street Fighter, liked that one. And then there was one like Street Fighter with a different name that was on the Mega Drive. Streets of Rage. Used to play that with my sister all the time. 2-player, 2-up. Yeah.
Yeah, we're talking about RetroPie, which is one of the things you can do with you can play old games now everywhere, it seems like. You can buy these mini little Super Nintendos that are kind of like basically a RetroPie in a box, but there's only a dozen games. Or you can get a Raspberry Pi for less than $100 and then put RetroPie on top of it, which it's actually really easy to do nowadays. And then you have to go find ROMs, which you tend to be able to find them pretty easily nowadays on the internet. And you can load up all your own your favorite old games. So that's one use. Not necessarily... you don't even need to watch us talk about that, because there's so many different RetroPie channels on YouTube. You can go learn about all that stuff.
Someone was asking, what is he saying? Faasd? And so just put it into the chat. I don't know if I can share links, but I've just sent it in, guys. So you can have a look at that. Saw some other people were talking about M1s, Raspberry Pi, Graviton, and compatibility, and I'm sure we can get into that later as well. But yeah, there's Faasd. So we have a cute little tugboat, and you're probably thinking of container ships if you've been watching the news, seeing the Suez Canal getting blocked by a huge one. And I resisted it for as long as I could, and then I did my own little spin on that. The huge container ship was obviously Kubernetes and Istio. And then we had K3S was the smaller boat at the back, and Faasd, I'll give you that on Twitter. Faasd was the actual like tiny little tug at the front. It's just pulling along a few containers for you, just enough functionality to run a web server, a portal, a function, a database on a small VM. There we are.
I saw you post this the other day in your email updates.
Sponsors email, yeah.
Yeah, and it's a pretty good one. Because Faasd is he pulling away fast? Actually, is he tugging? Is he pulling the big?
He's trying to tug it free, I think.
Yeah. There's the memes on Twitter about this boat are fantastic. But yeah, I haven't tried Faasd yet, but is it meant for one machine or is it like, because it's not using Kubernetes behind it, right? It's like you said.
No, it's not. It's meant for one machine. So the idea is that you might have a few functions, and if you wanted to use Kubernetes, which by all means go ahead and do that, it probably costs you $30 a month on DigitalOcean to get it, squeeze it as tight as you can,
right?
Or put K3s on a $40 a month VM, if you want to risk things. So what do? You just want something that's easy to manage. Maybe you deploy it for a client, one of your consulting clients, Bret, or one of mine. And let's say it just receives a message, sends an email, right? I have an example of this. On the Faasd book itself, if you buy, it's not live today, but if you were to buy the $50 DevOps Pro tier, it would then email you out a code for the video as like an upgrade, because Gumroad doesn't support that. I didn't want to run a whole Kubernetes cluster, $120 a month, just to be able to run one function. So with Faasd, I just drop it on a VM, use Cloud Init, set up a function, I'm good. I actually have that running on a Raspberry Pi and costing me nothing.
Right. That's pretty cool.
Yeah. So you can do anything that you would do with OpenFaaS. You can even do more with this as well. You can add a database, have stateful services running there, have a Grafana, and that's all done through what you'll find quite familiar is a Docker Compose file. So your functions are going in the normal way through the CLI, the UI, or OpenFaaS YAML file. But then you can have all these extra stuff along with it. So you get the base stack, and then maybe you want Postgres, you can add it in. Maybe you want Redis because we don't want to keep emailing people. I'm going to debounce it a bit. Or maybe you're running your database in the cloud somewhere on a free tier of RDS, and you connect it in. So it's very versatile. If you've got any kind of side project, it just means there's a very easy tool chain to get started. Right? You just want to write a bit of code to process an event, or maybe a web page, write the code, Faasd CLI up, point it at your Faasd instance, and you've got it live.
Nice. Question. Let's see. Slightly different question. I'm going to change topics because we're getting questions fast and furious. Paul's asking, is there a single ARM build so that my container runs on my M1 Mac, a Raspberry Pi, and an AWS Graviton instance?
Yeah, so when it comes to what we were talking about there, Faasd, for instance, OpenFaaS has got a built-in command that will build a container image with, let's say it's a Go program. It will cross-compile it if you want to in all the platforms that you ask for. So 32-bit Raspberry Pi, 64-bit Raspberry Pi, which is what you'll get on your Docker for desktop and on your Graviton, and an Ubuntu Raspberry Pi if you flash the OS. Plus, then you can have it run on your PC with the normal x86 instruction set. That's all built into the tool chain. There is a much longer way of doing it, which is using different tools like Buildx, building your own Docker file, making it all multi-arch, checking all the base images. And so if really you just have a small microservice or a bit of code to run, we've got it all packaged for you. It's really easy to use. Otherwise, look at how we've done it and dig into each part, and you can just reconstitute it yourself. And yeah, it's absolutely possible to create a Docker image. For binaries, you would need to, if it's Go, cross-compile it for each target. Maybe have 5-6 binaries at the end of that. Very easy to automate on a GitHub action. We've got good examples of it in Ketchup and Arcade and Inlets. And you probably do both, right? So you ship your code in a Docker image. Maybe it's a CLI. You also ship it in a static binary. So that's how we would go about it. And then if it's something like Node.js, again, in Docker, in the world of Docker, you do have different multi-arch images. And so you can use them as well. You have a node image that will just run on all of them. It's not automatic. Somebody is being paid at Docker to maintain them and keep them multi-arch. It is a lot more complicated. And if you're only targeting Graviton and your Raspberry Pi, you could just build it for a single architecture. Right? You don't have to have it support PCs as well.
Yeah, and that's a topic I definitely want to get into because, so the first thought I have, and so people that have watched this show all year, this is probably the third dedicated ARM show this year, and I think I maybe had one last year, not including our conversation last year, and so this year, largely due to, for me, three things that happened for me. One, I got an actual Raspberry Pi, so that obviously increased my interest. Two, I saw the announcements around the AWS Graviton 2. So these are the second generation of AWS ARM servers, and they're much better There's a much higher end performance coming out of them, and they've lowered the price point. So their marketing terms talk about basically you're saving 40% on a per workload, per CPU cycle performance comparison, which that was the real challenge for me with the early Gravitons, the early ARMs was, yeah, sure, they were cheaper, but they were also a lot slower. So what am I really getting? And I asked that question a couple of years ago, and it
depended on the workload. Only the Raspberry Pis were slow and bound by I/O. That you have like the Cavium Thunder X was one of the first big proper servers that Packet, now Equinix Metal, were shipping and putting in data centers. They were very, very fast.
Yeah.
Had loads of cores, loads of memory, NVMEs, the works. Today, you have Ampere, and they've launched the Jade based upon the Ultra platform. That I think that can pack something like 180 or more cores, and a lot of RAM. So if you have access to one of those, and the Graviton systems are pretty similar, there's a lot you can do with it. It's also super expensive. So you need to make sure you're utilizing it correctly, and that you have the workloads ready for it. It's very well suited to something like containers, loads of processes. They can all pin to a specific CPU, for instance. But it isn't great for Kubernetes in that sense, because Kubernetes limits you to 100 plus or minus pods per node. So if you've got a server with 256 gigs of RAM and can only run 100 processes, unless they're all RAM or CPU bound, then going to be much luck, right? It's not going to be much use to you. So then having an edge rack, perhaps you're working on Amazon's cloud, right? And you say, right, look, I want to put this on premises and get a Bitscope edge rack. With this, the use case the guys have, Bitscope that develop this, is they'll take like some applications deployed to EKS or ECS. They'll bring them, they'll help a team migrate them to Raspberry Pis, and they'll netboot these using a similar technique to my workshop. Maybe add an NVMe under each of them. Mine have got local storage here. And then you can run that application in a private cloud. On the back, it has very cool stuff like automatic fans. It's got a serial port and BMC. So you can actually control the firmware of each of these Raspberry Pis remotely. You can boot them up, turn them on, turn them off, as long as one of them is good. And so I think this is very interesting, is what does Kubernetes at the edge actually look like? Now that we have this K3S, it's become a CNCF project. There's training courses, there's certifications, there's all sorts of things, managed services built upon K3S. What is it going to look like to take one of Bret's clients and move them from these expensive EC2 instances to maybe an edge rack running in their factory, right, or in their office?
Right. That's a great question that I have not asked. While we're talking about these different types of clusters, so obviously Raspberry Pis are not the only way you can put ARM on a server, but you had this post from about a year ago showing your history of all of the different ways you've built stacks of Raspberry Pis and turned them in, not always Kubernetes, but turned them into clusters of workloads. Early days, I guess, was Swarm.
The one that I did at DockerCon there, 2016, that was one that I really enjoyed. It had real sensors on each node. It was the classic Docker Swarm, so going back a long time now. Redis, and all sorts of things that helped you monitor the temperature of different sensors. And then you'll see as the journey sort of migrated away from Docker Swarm to Kubernetes and then onto K3S. You look back and there's a bunch of tools that are being built as part of that. I think they list them towards the end.
Yeah.
One of the tools that I'm wearing the t-shirt of it here, Inlets, that I particularly like, I've always wanted this tool, never able to find it exactly in that format. It allows you to get remote access to a service behind almost any kind of network conditions, whether that is a carrier grade NAT. There's a guy in South Africa, Ruben Becker. He gets access to his Raspberry Pi or his server actually through Inlets, through carrier grade NAT, where your IP isn't just changing. It's like you don't even have one. You don't have your own IP. It's all double natted. So he's been able to use it there. We've also got customers in production. I'm doing a deployment with a customer right now, and they have different on-premises sites with a legacy application. They're running a tunnel there and bringing back an identity server, in each case, back to the production environment. So they have a centralized cloud, and then each on-premise runs an identity server, and they allow users to log into this bigger cloud application where they're doing all the new development. And the older one is allowing them to effectively federate in. Now, one of the things about ngrok is that I've always liked it. I've always sort of used it and gone to it. Is the limits got stricter. So they have 40 connections per minute, 7-hour lifetime for a tunnel, various other things. You can pay, but you're still not hosting it. And as a Docker enthusiast and as an engineer, I wanted to create something that could help me there. It also was blocked at any company that I'd worked at. So if you host your own tunnel server, well, it's not going to be blocked, is it? And the traffic goes over a WebSocket, which means it's always outbound. That picture's showing you there. If you zoom in on it, that the client is on your laptop. Let's say you're running, that's perfect scale, a Node.js website. I saw Alistair there. Alistair has often helped me out with a blog post or a draft, and he'll share it through an Inlets tunnel. So you're running it, it's on localhost 3000. You then set up the client, that talks to the server, and then whenever somebody pokes at the server, it just goes back down the WebSocket and reaches the internal application. Right? So we've got our site.com that our user is accessing there, and that's really just going to go back to localhost port 3000 on the other side.
So where would you run in the context of like a Raspberry Pi?
Yeah.
Is that something that you would run at home? I'm trying to think about where
the exits. So what's the challenge? What's the problem we're solving? I've got a home lab, or I've got a corporate server, or I've got a Raspberry Pi, or I've got my Docker desktop running Kind. And there's no way for you, Bret, to access that, is there?
Right. Nope.
Right. You can't get an IP address because I don't have one to give you. So
other than watching you on Zoom.
Who has lots of IP addresses?
Clouds.
So I ask Amazon, can I have a smallest EC2 instance that you've got, or DigitalOcean? Like, yeah, sure, it's $5 a month. I get that VM. I then install an Inlet server on it. It listens on a control plane, a WebSocket, securely with a token. The next step is I run a client. Now, the client is a Go binary. Again, it's multi-arch. We're talking about ARM. So I actually run it on a Raspberry Pi, or I run it on my PC. So when you get traffic on this domain name, just poke it over there. That's where it's going. Right, and I can have several of those. So one of the things you can then do is access that DigitalOcean droplet, my $5 a month droplet with 1,000 terabytes of free transfer. It goes down the wire to my house, into my Docker desktop, into my Raspberry Pi, or wherever it is. And it just works. It's pretty reliable. And then you can also do TCP if you want. So if you wanted to actually SSH into this, you might Noctura fan on there. I love these.
Is that quiet?
It's very quiet at the moment.
Yeah. Okay.
So I could set up SSH server on here. I could then tell my Inlets server, look, if you get any traffic, it's going here, right? Port 222. And then when we hit it, we'll just end up on it. And the first time I did it, I was just amazed because I thought, why hasn't anybody done this before? And I made it an open source project. And then I soon realized that these did exist, but it was always a commercial solution and you could never self-host it. It was always SaaS-based. So this was one of the things I wanted to do. And so whilst today there's Inlets Pro, which is a much better version, much more versatile, has lots of automation tools, works directly in Kubernetes. There's a free one out there as well, but you do need to think, is it worth your time to noodle around, spend a weekend or several nights just hacking away, trying to figure out how to set everything up with the free version? Why don't you just get the pro version off the shelf, use a tutorial we've written? So it's out there. The open source one works pretty well, but if you want to support the project and see it grow and become even better, and also access all the integrations, like the pro version, we've got a personal license out there, and it's quite often there's a discount or something running.
Very cool. And that's inlets.dev. I put the link, the GitHub link, also in chat. Yeah, and people can check that out. That's a great example of a businessy version of using a Raspberry Pi, unlike my RetroPie example. That's a more business version. You actually have you showed me this video, which I have not watched yet. Probably going to watch it later because it looks like a pretty good one. But it's the past, present, and future of Kubernetes on Raspberry Pi, which, I think that's kind of necessary because as we get more interested, because some of the questions that I want to get to in chat around, porting apps to ARM, building apps in ARM, we can maybe get a little bit more detailed if we want. Michael Irwin's got a question about Pi clusters running offline, stuff like that. I think for everyone, you gotta sort of have to understand the journey that we've all had to come through in order to know where we're at now and what's next, so you can prepare for it. Because I think ARM is inevitable and it's coming. There's going to be a day where, just like Kubernetes, for a lot of us, management came to us one day and said, "Are we running Kubernetes? Yes or no?" And it wasn't a question of do we need Kubernetes or whatever. It may have been the same thing for Docker too. Like, once thing gets into the zeitgeist, some term of technology gets into the zeitgeist, and if companies like Apple and particularly AWS are marketing the attributes of ARM as like this, from their marketing point of view, everything's wonderful, everything's perfect, money saved, better battery life, blah blah blah. And so I'm imagining a lot of us are going to have answers that we never had to have before around why are we running ARM, or are we running ARM, and why not? Like, those are the kind of questions. And developers have normally never. Most developers that are younger than me haven't in their lifetime had to worry about multi-platform. That's kind of one of my topics for today. I thought would be good to talk about.
It's not that mainstream, but I actually think, I'm just thinking now that it would make sense for us to do a demo and just show people how we can demystify this.
All right.
Okay. Now, there's a demo of this in my ebook, or Serverless for Everyone Else. It's just an introduction to the use cases and how to basically go and use this stuff. And I've got a repo, and it deploys into my house through a GitHub action, multi-arch based. It uses GitHub's cloud to build everything as well. Just looking for my example. I don't know if we've got Alistair there.
Yeah, while you're looking for that,
because I'll share. It doesn't matter because we won't have to use this. We won't use a GitHub because I can't find it. But I'm going to share.
Okay.
It's probably going to be small, so I might have to go a bit bigger on the screen. Put the side.
Let's see. Make that S2.
There we go. Okay. So I've got a terminal here. I'm actually on if we look at what I'm on, this is a PC. You see that?
Yep.
What I've highlighted. Effectively, it's an Intel NUC.
Can you zoom in a little bit?
I have zoomed in quite a lot already, but I can do it again.
Okay, so we have mobile watchers.
Yeah, if you're on mobile, you won't be able to follow this. It's just going to be too small. But we've got x86 64, which means it's a PC. It's an Intel NUC. Great. So where things start, how they start life tends to be creating a Docker file, right? Now, the OpenFaaS CLI can do this. So if we do new language Go, what we were talking about earlier, we were talking about subtitles. We have a Golang function that does subtitles for YouTube videos. We then get this templates folder, and within there's a number of different templates. Most of these are multi-arch. If we look at our Go one, we find a Docker file. When we open this Docker file, we start to see some things we're not used to seeing here. Build platform and target platform. And we're seeing this is an env subst, bit difficult to say. And it's saying, look, if you've got one of them, use it. Otherwise, it's always that. Okay. And so at the top of the file, this is a bit that's new. It's this platform. So when I build this for my PC, Linux AMD 64, if I build it on a Raspberry Pi, it should get injected as a Raspberry Pi. But also, it then allows me to do a build where I'm shoving in 5 different platforms and it's iterating around and building a new image for each of them. Does that make sense?
Yep.
Then, once we've added a code, always tend to have a Go build somewhere in a Go program because it's compiled. If it's Node, we don't have a Go build. So we actually build in the target platform. What I've done is an optimization to build in the build platform. So if I emulated a Raspberry Pi, it will build as slow as a Raspberry Pi or maybe slower. Right? So what I'm able to do is a nice hack here. I'm saying my target OS is a PC or Raspberry Pi, whatever, Windows, Linux, Darwin. And then I do my build, get a binary out the other end of it, and then I tell my code to run it every time it starts up. So I've got in another folder a handler, just says hello Go. I'm just going to change this to say your subtitle was instead. And we'll Go format this because the OpenFaaS template checks that. Okay, the next step, if we look at this OpenFaaS YAML file, is we'll see an image, and that's just a Docker Hub reference. So because it's going to be a multi-arch image, there'll actually end up being other digests that are pushed up, one for each platform we want to build, and then they'll all get mapped back into this top level one. If I put my name in here, I'm already logged into the Docker Hub. We should be able to then go and actually see all the images being built. Now, the simple build is only going to create me one for my platform. What we need, and I may have to potentially run another step here, is the publish command. And the publish command needs some indentation fixing there, is using Docker's Buildx project. Now, Buildx and BuildKit can be used together instead of normal Docker build to get multi-arch images. It can do other stuff as well, but that's the main thing that we're getting, is this is just running the command and inputting these various values. So AMD 64 is our computers that we know and love. AM64, ARM64 is the Graviton, the Ampere, or Ubuntu if it's running on here. And then ARM7 is your Raspberry Pi OS. These are just standard names. So that's what we want.
Yeah, that's a good point. I want to pause there for a second because for those that are basically, they're just considering what if my apps did run on ARM? What do I need to do? That is like one of the first steps. Like he's breaking down the Docker file and talking about building these multi-arch images, because that's not what happens by default. Is that you have to know what your target platform is. And, when we talk about Apple M1, that would be, just like you broke it down, that's the ARM64, that's the 64-bit ARM processor. Older ARMs. Here, right? Yeah.
We've got the two builds. We've got Linux AMD, we've got ARM, Linux ARM64. Now, the Mac is not Linux AMD 64 or Linux ARM 64. It's a Darwin ARM 64, and you can't have a Darwin container. So for a Docker conversation, it's irrelevant. Actually, what ends up happening is inside your M1, pull him up here. When I go into this and run Docker preview, Docker desktop preview, I'm getting a Linux VM, a Linux ARM64 VM. So if I want to target this, what I've got highlighted there, that's a platform that we need. But quite often, if you're building on this, you're not deploying to Linux ARM64, unless it's very rare that you would be. So you probably want both. You can't test locally unless you've got the ARM64, and then you can't deploy to your production server, your EC2 instance, unless you've got the AMD64 in the bundle.
Yeah. So the earlier question around can you have an image, a separate image per platform that you have to build separately, like he's describing and showing, but Docker makes it easier because they create this manifest file that he's talking about that hides all that complexity. Yeah, this is a great example. I'm glad you're pulling that up.
In the old days, what we would used to do is build individual images with different names and push them. You can see these are actually almost like a headless image. There is no tag with that. But if you look at some of the older OpenFaaS ones, you'll see it will have a tag of -armf, -arm64.
Right.
And then right at the end, after they were pushed, we would then create a manifest. Buildx can do it all in one shot, which is really nice. So this is the one that I can run on my PC. That is the one that will run on a Raspberry Pi. Now, because it's a multi-arch image, whatever computer I'm on, I'm going to go over to my other Intel NIC. I can run this. Start Docker on it. And I'll be able to do a Docker run, which will do a pull and then run it. If I log into a Raspberry Pi, I'll get exactly the same result. But the neat thing is that I can also deploy that to Faasd because it's a multi-arch image on my Raspberry Pi. So if I do a list, I told you guys earlier, I've got this treasure trove running there. I've got my Gumroad functions running there. So let's try deploying it there. So all I do is deploy. It's called subtitled text YAML. And Faasd is actually, it's synchronous. So Kubernetes, you deploy, it goes, yeah, fine. But then you have to go and wait and look for its status. Faasd is like, just going to wait until it's ready, and then it'll come back. So that was how long it took to download. And now we can curl it. There it is. A bit bigger. Right? But the cool thing is, remember, this is on the internet with Inlets. So I can just go faasd. What is it? exit.openfaas.pro. I think that's what it is. There. And you guys can actually access it on that URL as well. So Bret, if you were quick at typing, you could type that in and you'd be able to access it. So whatever is on my Raspberry Pi can be accessed that way. And I can also remove it. And what we've been able to do is, OpenFaaS very much about the developer experience. It's encapsulate to the degree that you're not even aware that all these things are happening and just handle it all for you. But if you are just wanting to get started out, it's a great way to start. Otherwise, dig into how we've done it. Look in our templates. Maybe find the one for another language like Node 14. Just see how is it different? What steps are being taken? Can you adapt it for your own purposes? In many cases, you'll be able to.
Yeah, it's certainly more work to be multi-platform. I'd say that we're not to the point yet that that's suddenly a free thing that just magically works. But I think that it's easier now than it has ever been. And for those of you that are interested in, especially if you're going to buy an Apple, if you have Apple devices, here's another thing. We haven't actually gotten down this road yet, but there's a significant portion of developers that are on Mac. And within less than 2 years, if they want to start buying new Macs, they will have to be on an M1 or M2 or whatever the next processor is. So it will be ARM, and then suddenly they either and because the other thing here is that Docker Desktop does emulation across using something called QEMU. We've talked about this on this show, so if y'all are new to QEMU, go back in the YouTube archives. I've talked about it several times over the last couple of months. And so that's a great feature, but it hides a little bit of the complexity of what's really going on here. And not everything works perfectly on QEMU. So my prediction is ultimately that what Alex has known for 5 years, and I've only started learning this last year, like most developers will eventually have to learn, because if they're going to be doing containers and they have Mac people in their shop, those people will eventually be forced to deal with the ARM problem. Thus, the team will have to care about multi-platform, even if it's just for local development. So I feel like it's Apple rather is driving us all to this eventual conclusion of developers and now DevOps ops people like me will have to care about multi-platform, where we haven't had to care about for the last 20 years because we've all been Intel. And, most 99% of things at least have been.
I mean, it's not just ARM though, is it? I mean, it's RISC-V as well. There's a new foundation for RISC-V. It's getting a lot of traction. People have ported Kubernetes to it. I think it's going to get a Go build at some point in the future as well. So what we're starting to understand is that there's not just Intel and AMD CPUs and targets, and RISC-V is going to be in a data center probably at some point, if not at the edge. We're seeing ARM now with 8 gig Raspberry Pis. There's no reason not to consider it. Graviton, and that's not the only ARM processor you can get. Obviously, you've got Ampere as well that are going pretty strong. One of the things that we were talking about earlier before we started the show was netbooting, and that kind of ties in quite well to the idea of Raspberry Pis. You said, okay, so I'd only really want to take that course if I had a ton of Raspberry Pis in a cluster. And so I said, well, what if you had a security camera under the eaves of your house and it was actually really hard to get up there and you paid a guy, contractor, $200 to come and fit it, right? You've got a power wire network. Well, actually, in that case, you might want to netboot that, because you never really want to go up there and replace its SD card because it's run out of writes. I have a number of Raspberry Pis on my desk. These have all been netbooted in different ways. The other thing is that you can then also just log into one without logging into it, edit its file system, change its Wi-Fi password, because they're all mounted on your NFS server or your iSCSI server. So it's network storage, not local storage, which means that I can go into a directory and I'll see a ton of different serial numbers. All of those are the root file systems of the various. If I can put this back up again, maybe I can show you. I can't netboot any for you today, but if we go and have a look at, are we on now? If we look at the TFTP boot folder, we've got all these different serial numbers, and that's what identifies each Raspberry Pi. So when you plug it in, you can run a command, find out what its ID is. You can create a boot firmware for each one independently. You can then also, as I was saying about the root file system, do one of them for it. So if I have a look in here, this is all covered in the course, so don't feel like you have to take notes. But if you look at the host name of that, the host name of another one, we get to see they're actually there, and I can edit this, whether it's online or offline, and those changes will reflect on it. And that's so much easier than actually physically walking over to Raspberry Pi and doing something to it. Right. So that's one of the benefits of it, right? And you also get to learn all of the cool stuff that goes behind it, like what is actually TFTP. Have you ever used that in your career?
Yeah, in fact, we didn't actually talk about this before the show, but
there we go.
I did a lot of netbooting and TFTP stuff early on in my career for DARPA, which is the U.S. government organization that's all their like secret stealthy projects. And so it was a classified project, but essentially what we were doing was we were building labs that we would build a rack of servers within an hour, and then they would destroy it through the network, like basically hacking the crap out of it, and then we would have to completely wipe it and start from scratch. And so we needed a netboot solution in order to rapidly, and this was before the cloud, before we had anything, it was just a bunch of Dell servers sitting in a rack, and it was really hard. I mean, it took a team months just to get all this to work together with properly, boot loading and then starting the OS install. And this was Windows. We were doing Windows and Linux. Like we were doing both. This
Windows
was like
is a bit
2002.
harder,
Oh yeah.
but Linux hasn't changed, because I remember doing this 20 years ago, and I did it exactly the same way in my school. The project I was using was LTSP, Linux Terminal Server Project, something like that. And the idea was that you put a floppy drive in, and that was all you needed. And you had a thin client that was then booted over. I was using an i386, can you believe it? And booted up 10 other PCs running off it. What happens is the unprovisioned server with the Raspberry Pi starts up and says, look, can I get an IP? The DHCP server that gives IPs out will go, yeah, got one for you. By the way, I've got TFTP as well if you want that. It will then go, well, actually, I'm going to try and boot off my hard drive first. Oh, that didn't work. Okay. Mr. TFTP, can you give me a boot file? And it won't actually have like a, can I have it and is it there? It tends to be, can I have this one, that one, and the other one? And whatever comes back based upon the firmware it would then go and boot with. So it gets that, loads it into memory, it's booting up. We then have the kernel loaded in, and the kernel will have a command that says, this is your NFS path. This is where you need to go to start the rest of the system. And then in this case, it's saying, look, I want to mount an NFS. It mounts it. That's a root file system. That's in our exports on the network server. And then we're good. We're up and running. We've got much faster storage than we would have with an SD card. Also, if you're thinking of having 8 of these, or like a classroom of 30 of them, the storage, if you wanted an SSD, would be quite expensive for 30. Right? You only need one server, and then you can boot all of them off it and share that. Right? At some point, it might start to degrade, and bandwidth might be a problem, but it's pretty, it's pretty tried and tested technology. It's been around for a long time.
Yeah, it's funny that you mentioned that because it's at least 25 years old. The TFTP, the boot order, booting from the network, basically any machine anyone has nowadays. Well, maybe not Macs, but is anything with a BIOS that you can get into or a boot firmware that you can change. You can usually boot to network, but the trickiest part of this is learning all the different protocols, learning the different methods to connect these things, and that leads me to your course because I wanted to make sure we mentioned that.
Exactly.
Yeah, you have a course on basically how to do all this.
Yeah, and it walks you through everything, and you don't have to be an expert, because in most cases what it will do is there'll be a script. You use a script to flash the firmware on the Raspberry Pi and change the boot order, because it doesn't have a BIOS like we used to reboot it and hit delete. It's not like that. It's a bit different for the Pi 3, and again, you can find all this information, just like I said with Inlets. If you've got 4 or 5 weekends, or it took me actually 2 weeks to learn all this and make it automated, literally.
Right.
If you've got 2 weeks of your own time and you don't value your time more than the cost of the course, then it's a no-brainer. Do it in your own time. But actually, I think as developers, one of the things we tend to do is undervalue our time. And so whatever it is, $50 or $100, think about what your paycheck is. It's like a tiny fraction. Have a lot of fun. And you might even be able to use it at work, like Bret did, and go and hack a server and rebuild it.
Yeah,
but once you've got that under your belt.
Sorry, go ahead.
Once you've got it under your belt, it's like, okay, great. Now what? So we've got that security camera scenario. We can build a Kubernetes cluster with that edge rack I showed you guys. You can get ingress in, perhaps with Inlets, remotely manage it. So what's cool about cloud Kubernetes services is that you can get a kube config on your laptop. I can run it in Peterborough, access my Civo cloud cluster. I can then get on a plane to San Francisco, and before my demo at KubeCon, I just run kubectl get nodes, and it works because the control plane is public and secure. Well, with your Raspberry Pi cluster, net booted or not, if you have an Inlets in there, you can do exactly the same thing. So it's actually pretty interesting for that point of view. And then I met somebody on Twitter last week that don't use containers at all. And they were net booting all of their Raspberry Pis, running things like Plex and other stuff like that. Just the benefits to the storage.
The Plex world is vast, and it's probably one of the most popular questions I get for home hobbyists or people that are building tech at home, home automation, doing things in their house, wanting to store all their videos. They start diving into Plex, and I get a steady stream of questions around Plex in Docker, Plex in Kubernetes, storage across nodes. How do I make this redundant? And so for those of you that haven't found that niche yet, if you ever wanted your own home media server, Pies with Plex in a cluster is a pretty cool thing. Yeah. So netbooting with storage and NFS is probably the next level. That's a more advanced option, but that could be really cool for a home project, I think. In fact, this leads me to
RetroPie.
Yeah, right? I was going to ask you. I could do that for sure. I now that I'm getting into this more, I have like the single node. I think the Kana kit or whatever the name is of that company. That's the one I got. And then I stumbled on, and I'm not sure if I have this link up, but I stumbled on to these pre-built Raspberry Pi clusters, and I think it's the Turning Pi.
Yeah, I have one over there actually, Turing Pi. The version 1 is running on the CM3, so it is a bit slow. The I/O isn't quite up to Kubernetes, but it can run Faasd. And there's a guy in the community, Johan Siebens, he has a really nice tweet or blog post, and he was running like an individual Faasd 7 times, distributing the functions between them. He was having a lot of fun, put inlets on it. But yeah, they're great for learning, but I would probably say you're best off with a Raspberry Pi 4 right now. It's going to give you a better experience with everything you do. You get a lot more RAM into the picture. But I actually was trying to netboot my Turing Pi, to see if I could offer that as well for this course. And who knows, we might get there. I spent like a day on it, and I didn't get any progress. So it's debatable as to whether it would work.
Yeah, and what we're talking about here, and this is all stuff new to me too, for those of you in chat that are just maybe like we're down a rabbit hole, but with the Raspberry Pis, you don't have to have just something like what I bought.
This is what you're actually going to want, though, Bret. This
is what I bought. Actually, I was given to it free. Actually, I think it was Linode hosting that got me one free.
Up.
Oh, let me get that. Let me get that shot.
So this is an SSD. It's an NVMe version. It's not running on SATA, so it's about as fast as you can get. And I've taken the metal insert off it that you'd normally have. It's a PCI slot, this, and just there we are. I've now got a Raspberry Pi 4 carrier board plus a CM4 module. I think this is a 4 gig version. It just slots in. And this is really where you want to go. If you're going to get one of those tiny clusters, the Turing Pi 2 will be able to use these.
Yeah.
And you can then go and actually can boot off this now. So you get the best of both worlds. Very fast, highly capable solution, very small. I think we're going to see some really exciting products around this. But again, they are in demand, and there's not a lot of supply around for them at the moment.
Yeah, we're talking about all the latest stuff too, right? Like this is all like the stuff, like it's not just because everyone's building PCs for Bitcoin mining, so it's impossible to find PC parts, but it's also like the newest Pi stuff, so everybody in the Pi world is trying to buy it. So, warning to those that are trying to get this stuff.
Yeah, go and buy your Raspberry Pi 4s. We don't get any commission on it, but you will have a lot of fun. You can then go and take my netbooting workshop, or maybe have a look at the serverless for everyone else. It's great on the Raspberry Pi. I'm running my Treasure Trove portal on there with my sponsors updates. I know a lot of people that have bought it recently. I think we've had something like 300 sales of the ebook, and then people go and try it out and play with it, deploy their functions, come and ask questions on Slack. And then you're getting to play with containers, as well as also not having to care so much about them.
Right. You have a couple of questions here. Does the workshop cover Arduino?
No, it doesn't. Arduino is a very specific IoT device, but I have got some stuff out there if you want to read it on the ESP units these little Wi-Fi chips. So let's say you wanted to run 5 temperature sensors in your house. What's it going to cost you? $25 plus another $15 for a power adapter, plus an SD card, plus a Wi-Fi chip maybe. It gets expensive. So you can actually just buy for about $3 this ESP unit, and you can program it in Lua, and it can then broadcast the messages over HTTP or MQTT. You can have loads of them. That's probably one of the cheapest, easiest ways of doing sensors. But you can plug them on a Raspberry Pi, and you get a full Linux operating system. There's some really fun products out there you can play with. Yeah, thank you, Yankee, for plugging the book. And he's written some really good blog posts for us on community as well.
Nice. Thanks, Yankee.
Yeah, so that's it. If you want to go super specialized, you can buy super specialized hardware like an Arduino or one of these Arduino-like components with Wi-Fi built in. You can get a Raspberry Pi, it's a full desktop PC in effect. So there's more moving parts. Do you really want to deploy that in, like, I don't know, if you're monitoring your greenhouse? Probably not. If you can get some power out to it, just run it a board that you flash and never think about again. You don't want to be thinking about CVEs and updating the latest version of Docker. It's overkill. But then a lot of the time, you might prototype something on a device like this, and that might be as far as you go.
Yeah. And all this stuff is, a year ago, even just, I feel like just a year ago, we had far fewer reasons in the business world to make it an objective to learn ARM. I mean, like playing at home with the Raspberry Pi, not a lot of people get their job to pay them to do that. But I feel like once you start seeing this stuff with the likelihood that everyone's going to end up with these, M1 ARM machines, if they're on a Mac platform or they have anyone in their office that's on Mac, and then we start seeing these announcements from the cloud providers about how their ARM, especially for particular workloads, these ARM processors will save you money. What I really like about them too, especially in AWS, is like they get 10 gigabit out of the box on networking, which you don't get with cheap servers on AWS, which is a shame because networking sometimes can really suck on AWS on cheap servers. So I like them for things that I need to do, networking stuff on. But the point of all this is that it gets you down this road of learning multi-platform. And I am very bullish on the fact that we suddenly, in the next few years, will all have to care about multi-platform in our development in order to support our team, to support the infrastructure we're going to need, if you haven't already had to go there yet with IoT and all these other variants. And I don't know about you, but I don't specialize in anything ARM, obviously, because I'm getting into it. So I don't get those kind of clients, but I can see how those clients eventually will start seeing the marketing. They'll start having the M1 Max, and they're going to start asking for multi-platform containers. And for all of us that are new to this, that means we're going to have to tinker. We're going to have to play with this stuff. And the way you do that is by getting something ARM,
I mean, I think we need to think about crossing the chasm, that diagram that the CNCF uses quite a lot to talk about early adopters, the laggards, and sort of the commercial companies that adopt stuff. You're a bit late to the game, to be frank with you, Bret. People have already asked for all these things. The ARM laptop from Apple did accelerate it a little bit. People are asking for Kind for ARM64 now, and it isn't there. It's not available. I actually did a bit of experimentation because I knew we were going to talk about ARM. I tried Kind. It's usually my favorite. Didn't work. It's not available. Okay. Then looked at K3D. That was available. So the guy that maintains K3D, he's aware of multi-arch, but people actually asked him for it as well, and he spent that time. So the burden is really on maintainers. Minikube also works extremely well. It used to be quite difficult to use. Had Docker machine inside of it. It was provisioning with VirtualBox. Now it can run on a Docker container, just like Kind and K3D. It's actually pretty fast. And both of them worked out the box. I then did a one-click install of OpenFaaS using Arcade, Kubernetes Marketplace, and that was that. And it worked really, really well. So these things have all happened. In fact, people like me and Ed Violetti, Equinix Metal, many others have been almost like campaigning and lobbying different open source projects and different companies for years. We did it
Yeah.
with Docker 6 years ago. We then did it with the Raspberry Pi Foundation because of something we needed in their kernel. We've then done it with Minio because for a while they weren't multi-arch. We brought that back. And you'll see with Cert Manager, that happened in late 2019. In fact, a lot of the ecosystem is already ahead of the game. And it's folks that, like you say, like yourself, haven't had an interest in it or haven't had a customer asking for it. You guys are like, oh, we've got all this to learn now.
Yeah. Yeah, and that's the as far as you all have brought it, by the way, I've been seeing that because as I start to build things and I hit roadblocks, I will often stumble across a post that you made years ago in a GitHub issue saying, "Hey, can we get ARM support in this?" And
Yes.
it's always fun in GitHub, especially same in Stack Overflow, when you find an answer to your question and it's from someone you know, and
Yeah.
a lot of these times they will have built it because you asked for it and other people jumped on, piled on the question and said, yeah, we would like that also. So for those of you out there,
it's
yeah,
me that
sometimes they
asked
say
it, and it's so long ago I can't remember, and I go there and it's still me that was the last
Still there.
comment.
Yeah.
Or or sometimes I will contribute it, or I'll help the maintainer to understand how to do it.
Yeah.
With a Go binary, with a nice sample project called Release It in my account name, Alex Ellis Release-It. It's got a multi-arch build of GitHub Actions. GitHub Actions were always something that was difficult to use when it was YAML based. So it was, what was it before it was YAML? HCL. They had different iterations of it. Where it is now, it's matured and it's really easy to use. And so if you've got customers or users that are going to be multi-arch, undoubtedly you do have, very easy to give them support now.
Yeah.
You may find some things don't work as expected, like TensorFlow or something that compiles to C. Those are the areas where there's some ambiguity.
Yeah, I have stumbled into tools, particularly Kubernetes tools, which are like you're describing. There's some of the less popular tools have not provided multi-built binaries or container images or both, and so I'm piling on to whatever they've ignored of your request. I'm piling onto that. So I don't know if that'll help, but for those of you that are listening and watching, like this is how you get the tools that you're using. Be nice, right? Like, don't be a jerk because nobody likes to listen to a jerk. So be nice and request ARM support. Specifically, like you have to learn: do you need ARM 64? Do you need ARM v7? Or just ask for both? Because I like a lot of these contributors, like me, I didn't understand the different platforms of ARM, and so now what I'm seeing in some cases is they're providing. They do provide ARM 64, which will check the box for Docker Desktop on Apple MIM1s, and it might check the box for Gravitons, but it won't check the box for a Raspberry Pi out of the box yet, because I just recently learned that Raspberry Pi out of the box on Raspberry Pi 4 with Raspberry or whatever is still a 32-bit OS. So
yeah, that's right.
Yeah,
Raspberry Pi OS is 32-bit.
So I need a different platform for that, and that's not super intuitive. Yeah,
and actually, yesterday or the day before, it was this week, ARM announced ARM v9. So we're going to have another one. And, it's yet to become apparent whether there be backwards compatibility, forward compatibility, or how it's going to work. You may just be building ARM v7, v8, v9, RISC, x86. If before Phil Estes moved out of IBM to AWS, he would have probably asked you to build a PowerPC variant or an S309X. So you get these more obscure, sort of less mainstream CPU architectures.
Yeah.
Your CI is going to be a lot slower. You're building 6 Go binaries. That's just going to be 6 times faster than building one. It's just a matter of fact. Yeah, and that's one of the reasons we delayed it in OpenFaaS. We didn't want our builds to be taking that long. Now we've taken the hit, and it's much easier because we don't have to do any work. I used to have to log into an Equinix Metal machine, run my build script, push all the images. Then I'd log into a Raspberry Pi 4 with an SSD. I'd run the same command on that, it would push all the images, then I'd do the manifests. Now it's just all done automated. It took us 3 months. And part of the reason for that was that Travis stopped doing a free tier for open source. And so it was just where we had to move stuff, and we thought we'll just get it all right. At the same time, Docker started rate limiting users. So we moved it to GHCR. GitHub don't do that. But I am paying Docker my $60 a year so that I can push images, but I'm very much aware that many developers are just cheap at heart. They won't pay that. And so we put it on GHCR to make it available for a broader audience.
Do you use GitHub Actions now? Is that what you moved to after Travis?
Yeah, completely.
Yeah,
for everything.
I'm really enjoying them. And I'm now very bullish on GitHub Actions. It's like that is the place to beat. If you're going to do anything new CI, you should be doing it in GitHub Actions, especially if I'm assuming your code's all there. If it's not, then you don't have to. It doesn't make sense to do that, obviously. But for those of us that are used to just everything being in GitHub, a lot of my customers are now evaluating it or considering it and wondering why they're running their own CI, why they're running Jenkins or Drone or whatever.
Yeah.
And it's going to be the hard one to beat. It's like there's I don't know, 4,000 GitHub Actions now, and so a lot of these problems, like you're talking about, like the Buildx problem is kind of solved. Crazy Max is doing some really good stuff over with the Docker stuff.
Great.
Yeah,
great with that. I've just given you a repo, the release it repo I mentioned earlier. That's a Golang example, and you'll see the action in there. I love it when there's no Docker involved in the project because it's just so fast. There's such little stuff to worry about. And so that one is an example that's just pure Go, spits out the binaries that you want, and then uploads them using GitHub Action I wrote to your account. The second one is an Inlets operator. That's the one that can get you a public IP for your Kubernetes cluster for any load balancers that you have. And you see the example there. It runs through Docker setup Buildx, does the login, and it's just literally one command to publish. And it has the architectures in there that we looked at earlier in platforms field. AMD 64. I actually do ARM v6. I don't know why that's v6 because that's Raspberry Pi 1, and I don't think anyone will run on that. So I might change that to 7 and an ARM 64.
Yeah. So, what I have noticed is like someone in chat earlier was where was it? Biker was saying he said he even ported Bret's SH pod to ARM64 and other examples from the Kubernetes mastery course. So I think Biker, if you're still on, so that is the actual same thing I'm going through this month, and next month is, well, actually this month because it's April 1st, and then last month has been a lot of effort in going through all the courses and making them ARM compatible, specifically at least trying to do ARM64 is like in the bag, that can happen. But getting ARM7 is spotty, and then trying to go to ARM6, I just kind of gave up on that because very few tools out there have v6 support. And it's probably at this point an old Raspberry Pi that's so slow nobody wants to use it anyway.
So you're showing a few bits and pieces here. We've got everything in place. That's effectively going to do a very long Docker Buildx command. That's all this is doing. It's taking all of that in. It's going to do the cross compilation, push it. It's all automated. You can fork this. You can take that example. I don't mind. And I think I also sent you the Docker file just to show people again. Target platform is what it's going to run on. So if you do steps inside of that, you're emulating that platform. It's going to be slow. Build platform is the computer that you've got in front of you. So do as much as you can in the build. Only switch into target platform right at the end, or if there's something that you need to do in that platform, like, I don't know, build a C library in NPM, Node.js module, then it probably makes sense.
Yeah. Somebody's asking, what about GitLab CI? Well, sure, GitLab CI is fine, but I guess my point to that question when I was talking about it was that GitHub Actions, I think, is now the default. Like, if you've already got your code on GitHub, rather, you should be using GitHub Actions by default. And if there's going to do anything else, you now have to ask yourself, why do I need this? Like, is GitLab CI easier for me? Because I don't know, GitHub Actions are pretty.
It's not going to play well, right? If you're on GitHub, you use just GitHub tools. But yeah, GitLab CI is fine. All of these commands can be run with a CLI. All of them are just Docker build or Docker Buildx some variation on it. What you're looking at is magic, right? You're looking at the magic. And when the magic is taken away, you just got the bare tools, all the knowledge and experience and expertise. And when you look at OpenFaaS and you do Faasd CLI publish, we've taken that and removed it as much as possible from your consciousness. So that you're just saying, I've got this Raspberry Pi and my ARM64 server, and I'm going to deploy to both. That's it.
Right.
Build it.
Right.
You're not having to even think about the Docker file.
The one thing that we kind of hand wavied in magic, like you're talking about there, is that the way that that's working today on GitHub Actions is using Buildx with something I mentioned earlier called QEMU to emulate these different platforms. If you want to build natively on these platforms, then you have to get that hardware, which is we're not going to go down that road, but that's a separate conversation. But the nice thing is, if you are able to use Buildx, it can have this QEMU built in, or at least enabled, so that you can build multi-platform technically on an Intel machine. Or vice versa, you can be on an ARM machine and build for Intel. So that's possible in containers. Go building is the same way, but I would imagine that a lot of us, at least in my community, are not Go language people yet. So their work has not shifted to that language, unfortunately. We have a couple more questions. One is, how do you deal with storage in your Swarm Pi cluster?
Yeah, don't use Swarm at all. There you go. If you've got a Kubernetes cluster, what you can do is use the NFS provisioner. I detail that in my course. I've got links to it. If you've set up Netbooting already, you've already got NFS. It's just a little add-on. And what will happen there is, if it needs a volume on Raspberry Pi A, it will create it on the network server and then access it, mount it as a file system. So if your pod dies, it can then be relocated to another Raspberry Pi. There are other projects that I mentioned there as well, OpenEBS and Longhorn. They have slightly different requirements. But one thing that I kind of come back to is, if you want to start out, right, just with learning a bit of Cube, let's say, I'm going to show you something again. I can't remember if we looked at this last time. But if you want to start out, what you can do is run kind on your computer. That runs a Docker container. And the one, we see I've got this Kubernetes cluster. And then I've got my connection to it. But actually getting some applications inside of that is quite a lot of work. What would I normally do if I was you? Would I go, okay, I'm just going to go and install OpenFaaS, right? Oh, do you want the home page? No, I need the Helm chart, don't I? Oh, where do I go next? And it's just very difficult. And let's say you're installing, I don't know, 20 projects. All of them, you've got to go through the same process. When you get the Helm chart for OpenFaaS, you did some Googling. Like, okay, looks great. There's my one command. But then there's bits that you can change. Like, oh my goodness, all of that. How am I going to know what's right? Well, what we've done is, now my cluster's ready, is created a CLI for the community called Arcade. Arcade is an easy way to get apps. It's a Kubernetes marketplace. And it comes with an install command. We run install-help. Pretty much anything you could want here. I think we even have GitLab. Somebody mentioned that earlier. I can install GitLab in one command. This has made things a lot easier when I've gone to a client and say, look, we need some help marketing our cloud. For instance, Civo. We run a K3S service. So, okay, I'll do your blog post on setting up a TLS Docker registry with auth. We actually did this. It was 5,000 words to do it. And that was as succinctly as I could manage. The new way of doing it is one command, which is arcade install Docker registry. And that will literally do all of the 5,000 lines worth of work for us. Words, sorry. Same with OpenFaaS. We can actually just install it for you live. And then at the end, it's going to be able to tell you how to use it. You can get that message back at any time you want. So if we cleared the screen with info, and we get our info message back again. We can install the CLI. We can get the port up and running. See if we've actually got anything yet. Oh, this is very big text. So what if we wanted a Kubernetes dashboard? Again, this can be pretty tricky to install and get right because you have to create a service account for it. Have you ever had to do this, Bret, where you've installed the dashboard, you've got to do the service account thing, token and everything?
Yeah, I have to keep my
pain,
own,
isn't it? Right.
Yeah, I have to keep my own copies of their examples, and yeah.
Well, we just maintain it all for you. So I can just pull this dashboard up now. First thing we do is just follow what we're told. Done that. Next one, kubectl proxy. Run that in the background. Next thing, get the token for the dashboard. There it is. Then I just open it up. Got a token. And this is the experience that we created for anything that you want. There we are, got a dashboard. Like, I don't think I ever got a dashboard as quick as that in my life before we created this arcade app for it. And it just wraps up all of that operational knowledge. It's like having a Bret in your pocket. He just comes along and does these things for you.
You have a question. Arcade is cool. Does it work only with Kind?
No, it just works with any Kubernetes cluster. There's nothing specific about Kind. So I tend to work only with Kind. It's just my favorite Kubernetes at the moment. But I use it with Minikube at the weekend as well. Now, I actually had another use case, which I was doing some work for a client. We needed to make a Go program run in the background, so Windows service. It's actually quite tricky. Once I'd done it, I then needed a series of CLIs. I needed Helm, I needed kubectl, I needed Terraform, and I wanted all of those binaries. Well, Arcade can actually get them all for me as well. There's a list somewhere. So Arcade get Helm, it goes off and it pulls the right version for my architecture. If you're on a Raspberry Pi, it will pull the right version for that. If you're on goodness knows what kind of computer you're on, a Darwin PC, it will go and pull that down for you as well. Right. So in a very short period of time, I can just bang, 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 get all of these different CLIs in place without having to go off, just like the Helm charts. So this is a tool that I think, if you're getting into Kubernetes, you should have a think about trying it out. We've got Minio metric server. Someone asked about NFS volumes for their Raspberry Pi. That's here as well. And then if you couple this with Inlets, you can get a public IP. Once you've got a public IP for your Kind or your Raspberry Pi, you've basically got a fully functional Kubernetes, almost like a cloud provider would give you. You can access it from anywhere.
Very cool. I just realized that
yeah,
I think we did talk about Arcade last time, but
we did.
The utility of it,
get
something I keep forgetting about. Yeah, I don't remember that part. That's for sure.
We've got a sponsored app as well, and we'll potentially get some new ones of those in the future as well. And again, it's like, how can you sustain an open source project that's got a community behind it, that's potentially quite large and laborsome, without any money? And so one of the ways I do that is through the GitHub sponsors, and then to encourage people to become part of that and to feel that they belong. We've got updates there going all the way back to 2019 every week. I'll probably even be writing you one tomorrow, and you'll get that in your inbox. And Bret, you get these, don't you? Because you subscribed last time. Probably find an email from me. And so, yeah, it's a great way to keep in touch, see what I'm doing, support open source. Even if you say, look, Bret, actually, quite a lot of people say this. They go, why would I sponsor you, Alex? I've never used OpenFaaS, or I use OpenFaaS, but not at work. I say, well, have you ever Googled anything about Raspberry Pi? Then you've used my work. Have you ever used Docker? Then you've built a multi-stage build. And if you look at the docs, I wrote the docs for that. So it's almost impossible if you're in some kind of Go or container Raspberry Pi world to not have been using and relying on stuff that I've been building. So yeah, have a look at it. There's a couple of new features GitHub have, like there's like custom tiers, one-off amounts. These are things that they're putting in the works, and the more we can do, the more I can do for you. That's how I look at it.
Yeah, and you're everywhere on the internet advocating for not just Raspberry Pis, but Kubernetes, tools on Kubernetes, open source in general, the CNCF, and this whole new world of cloud native and DevOpsy type stuff. So I want to thank you because I really appreciate it. I enjoy the emails, the email updates. It's clear that you put a lot of work into those. I am horrible at newsletters and emails, and I aspire to be 1/10 as good and thorough as your emails are. I'm always looking for pictures too. I have to admit, I sometimes just scroll through looking for the pictures and the different tweets and stuff.
Somebody likes the pictures because I'll typically spend a couple of hours doing it on a Friday evening or Saturday morning, and sometimes people are like, why are you sending me an offer for something that you've made? And the reason is simply, look, if you sponsor me, I want to create more value for you. I want it to be interesting. And so if I give you 15% off Inlets because you're sponsoring me, don't be offended. At the end of the day, you can take it or leave it. You don't even have to read the emails. But what I'm trying to do is communicate with you that I'm a human being creating this software, and that I want to share the detail with you. And if you're interested, you can follow the journey. Sometimes there's stuff that's not about what I'm doing at all, more about business and marketing and growing community. If you're a sponsor, you can submit stuff for me to include. I'll include this live stream when we get the URL for it as well.
Yeah, and so those of you out there who are considering, if you're doing things like sponsoring this channel, you should look at expanding that a little bit. I personally try to add a couple every year to my repertoire, trying to find some good people out there. Like I've supported Alex for a little bit, and like the guy that makes iTerm, because I use iTerm every day on my Mac, is basically one gentleman that does it, and I think he's worthy of being sponsored by someone who uses his tools every day. So it's a great point you make that there's a lot of community contributions that aren't visible, right? Who made this documentation? Who added this PR to the app that I use every day, right? So, so someone like you that's been in open source for years, your teeth are in all of it, right? The effects that you have are all over the place.
The ripples are very real, and when somebody says that, like, why would I sponsor you if I don't use your work or don't use anything right now? It's like you don't realize like how much work people have been doing. Watch that video, Kubernetes, past, present, and future, and you'll just see how much work a whole ton of people have done on every level. So if you're interested in these things, you want to support it, fair enough. If you don't, then that's your choice as well. But I've got some other interesting things that are different from sponsorships, like the 2 courses at eBooks. And then a lot of folks are buying Inlets Pro to play with their home lab. Somebody asked, does it only work to expose stuff on the internet? No, actually, you can use it like a VPN. So if you wanted to, I don't know, run Postgres on your NAS, big fat NAS with a massive RAID array and WordPress in the cloud, you could do that. And you could privately tunnel it into your cloud instance. Nobody else could see it. Don't even have to put TLS on your Postgres if you don't want to, because it's encrypted. And that's like a hybrid cloud use case. So very versatile. Someone also asked, is it the same as Tailscale? Obviously, Tailscale is a SaaS controlled by a startup company, and it's really aimed at allowing you to access your home network remotely, but not being able to tunnel individual services or be able to like share stuff with other people. It's mainly about, what if I wanted a VPN just like at work and I want to bring all these hosts on? Inlets is more about individual services. You tunnel them publicly or privately. It scales really well. It's super easy to use. It's all hosted by you. You run it. It's very easy. And, there's nothing really that can go wrong with it. We've been running it now since 2018. It just generally works. Right? You're not going to be putting your video conferencing data over it, but HTTPS, databases, SSH, Kubernetes API, whatever, they all work really well.
Yeah, and yeah, especially if you're collaborating in a team and you need to constantly show other stuff to other people. There's a lot of people working in this space trying to solve this problem, and I feel like you kind of wrapped it up nicely a couple of years ago, and and allow people to do this without having, it's not a domain specific tool. It's not only VS Studio, VS Code or whatever. It's not only this particular app or
Yeah.
what this particular way of deploying something. So it's quite versatile. Well, it's been great again having you on the show, catching up with all these different projects you're working on and seeing the new stuff. I am excited to get more and more into the rabbit hole of ARM this year as I continue my learning and adapting to this new multi-platform world that is new to me, but not new to everyone else. And so I want to make sure everybody knows you can follow him on Twitter, Alex Ellis UK down there. You can see below is his head. That is his Twitter handle. And then alexellis.io for his website, alexellis.io.
Yep.
That's where you can get all of his email subscript, all the information about all the projects, all the great content he's created, the courses. It's all there.
Yeah, all the W's on that one.
Yeah. And I look forward to our next discussion and what new cool ARM stuff is out, hardware. I'm
likewise. Folks, just feel free to reach out to me on Twitter with a tweet. If you're in the OpenFaaS community, you've bought one of the 2 ebooks. There's channels where you can chat about that there. Same for Inlets. I appreciate all the comments. We've got some really good ones there. I haven't been able to answer all of them, but again, feel free to reach out. And likewise, Bret, great to be here. Thanks for having us on again.
Well, thank you. And for all of you watching, so this is another ARM episode. I probably need to make an ARM playlist at this point. But next week, we're actually having Mark Church, which Alex, I think you might remember Mark Church from Docker. He is now, I think, with Google, and he's in charge of GKE networking. He's going to be our guest next week. We're going to be talking about the evolution of the Ingress API into the Gateway API, and he wants to start getting the word out on that because they're going to do this big reveal for KubeCon this year. So more Kubernetes stuff coming. So join us this time, same time next week here on the channel, wherever you're watching it from the 3 different places we're live streaming. And thanks for watching this YouTube Live. Ciao.
Bye.